In the realm of network engineering, VLANs and VTP are not just mere acronyms, they are the backbone of efficient network management. VLAN, standing for Virtual Local Area Network, and VTP, short for VLAN Trunk Protocol, are integral components of networking. They are instrumental in enhancing security, increasing performance, and improving manageability of networks. Let's start with VLANs. They are essentially a way to logically segregate networks without being constrained by physical locations or connections. Imagine an office building with multiple departments. With VLANs, you can group all the computers in the finance department into one network and those in the marketing department into another, regardless of where they are physically located in the building. This not only boosts network performance by limiting broadcast traffic, but also enhances security as data is only shared within its respective VLAN. Now, managing these VLANs across multiple switches in a large network can be quite a task. That's where VTP swoops in. VTP is a Cisco proprietary protocol that propagates the definition of virtual local area networks on the whole local area network. To put it simply, it helps in maintaining consistency among all the switches in a network by controlling VLAN configurations across multiple switches. You can think of VTP as the manager of a supermarket, efficiently organizing and coordinating all the sections or departments, which in this case are the VLANs. With VTP, you can add, delete, or rename VLANs centrally, and the changes will propagate to all switches in the VTP domain. This significantly simplifies network management and reduces the chances of error. However, remember that with great power comes great responsibility. Misusing or misconfiguring VTP can lead to serious network issues. But don't worry, as we delve deeper into the topic in this series, you'll learn all about the best practices to avoid such pitfalls. Understanding VLANs and VTP is the key to unlocking the full potential of network management. So, stick around as we take a deep dive into the configuration of VLANs and VTP in the upcoming scenes. Until then, happy networking. Now that we understand the importance of VLANs, it's time to delve into the configuration process. Let's take a journey through the step-by-step process of setting up VLANs, a critical part of today's network infrastructure. First things first, we need to access the switch. We do this by entering the enable command followed by the configure terminal command. This puts us in the global configuration mode where we can make changes to our switch's configuration. Next, we create the VLAN. To do this, we use the VLAN command followed by an identification number. The number can be any integer from 2 to 4095, as 1 is the default VLAN and numbers above 4095 are reserved. For example, VLAN 10 creates a VLAN with the ID 10. Once we've created the VLAN, we can assign it a name. This is optional but recommended for easier identification. To assign a name, we use the name command followed by the desired name. For instance, name sales assigns the name sales to the VLAN. After naming the VLAN, we exit back to the global configuration mode using the exit command. Now, it's time to assign interfaces to the VLAN. This is done using the interface command followed by the interface's identification. For example, interface fast Ethernet 01 selects the interface fast Ethernet 01. Once the interface is selected, we can assign it to the VLAN using the switchport access VLAN command followed by the VLAN ID. For instance, switchport access VLAN 10 assigns the interface to VLAN 10. We then set the interface mode to access using the switchport mode access command. Now, we've successfully created a VLAN and assigned an interface to it. But we're not quite done yet. We need to save our configuration to the startup configuration file to ensure it persists after a reboot. This is done using the copy running config startup config command. To verify our configuration, we use the show VLAN command. This displays a list of all VLANs and their associated interfaces, allowing us to confirm that our VLAN has been configured correctly. This process can be repeated to create and configure additional VLANs as needed. Remember, each VLAN creates a separate broadcast domain, which can improve network performance by reducing unnecessary traffic. In a nutshell, configuring VLANs involves accessing the switch, creating and naming the VLAN, assigning interfaces to the VLAN, saving the configuration, and verifying the configuration. Each step plays a crucial role in ensuring that the VLAN functions as expected. With these steps, you have successfully configured a VLAN, a critical step in efficient network management. Moving on to another critical network component, let's explore these steps to configure the VLAN trunking protocol, or VTP, as it's commonly known. VTP is a Cisco proprietary protocol that propagates the definition of virtual local area networks on the whole local area network. To begin with, it's important to understand that VTP is used to synchronize VLAN information within a VTP domain. This is particularly useful in large-scale networks as it reduces manual configuration and the possibility of configuration inconsistencies. Step 1 in configuring VTP is to enter the global configuration mode using the command configure terminal. This is the mode where most of the router configuration is done. In step 2, you'll need to define a VTP domain. This can be done using the VTP domain command followed by the domain name. Remember, all switches sharing the same VTP domain name will share VLAN configuration details. Step 3 involves setting the VTP mode. There are 3 modes to choose from: server, client, and transparent. The VTP mode command is used, followed by the mode of your choice. VTP servers can create, modify, or delete VLANs and other configuration parameters for the entire VTP domain. VTP clients can't create, change, or delete VLANs, but they do propagate VLAN changes in the VTP domain. Transparent switches don't participate in VTP and only forward VTP advertisements. Moving on to step 4, we need to set the VTP password. This is an optional step, but highly recommended for security purposes. The VTP password command followed by the other password of your choice is used. Next, in step 5, you'll set the VTP version. 2 versions are available, version 1 and version 2. The command VTP version followed by the version number is used. Last but not least, step 6 involves verifying your VTP configuration. This can be done using the show VTP status command. This will display the VTP configuration details for the switch, allowing you to confirm if everything has been set up correctly. All these steps form the basic building blocks for configuring VTP on your network. They provide a robust foundation for efficient network management and are pivotal in reducing configuration inconsistencies across your network. Remember, while VTP can simplify VLAN configuration, it can also inadvertently propagate incorrect VLAN information across the network. So exercise caution and always double-check your configurations. In conclusion, mastering VTP configuration is an essential skill for any network engineer. It not only enhances your understanding of network management, but also equips you with the tools to implement efficient and scalable networks. With the completion of these steps, you have now configured VTP, further enhancing your network management skills. As we wrap up, it's important to remember the key takeaways from our discussion on VLANs and VTP. Let's take a moment to revisit the significance of VLANs, or virtual local area networks. They serve as an invaluable tool for network engineers by breaking down a larger network into smaller, more manageable segments. This segmentation not only boosts overall network performance, but also improves security by isolating sensitive data traffic from the rest of the network. Remember, configuring VLANs is all about creating these partitions and assigning them to the right network interfaces. Now, let's shift our focus back to VTP. The VLAN trunking protocol. This protocol is paramount in managing VLAN configurations across a large network. It cuts down on the manual workload by propagating VLAN information to all the switches in a network. Simply put, it's a time saver and a game changer. Configuring VTP involves setting up a VTP server and clients and making sure they are all in the same VTP domain. But it's not just about knowing how to configure VLANs and VTP. Best practices play a vital role in ensuring efficient and secure network operations. When implementing VLANs, it's advisable to keep the number of users per VLAN to a minimum. This reduces broadcast traffic and enhances performance. For VTP, it's crucial to maintain control over VTP advertisements to prevent unauthorized changes. Always use a secure password to protect your VTP domain. Also remember that VLANs and VTP should be used judiciously. VLANs can help compartmentalize your network, but too many VLANs can complicate network management. Likewise, while VTP simplifies VLAN management, it should be used with care to avoid unintended VLAN propagation. In a nutshell, VLANs and VTP are powerful tools that, when used correctly, can significantly enhance your network's efficiency and security. It's all about striking the right balance and adhering to best practices. With these tools at your disposal, you are well on your way to becoming a more efficient and effective network engineer.